Hi everyone, I am Trixie Marie Ann Balico and I will be your teacher for today's video. In this masterclass video, we will tackle about the basic integration formulas, the general integration formulas and the use substitution, and lastly, the technique of integration, which is the integration by parts. Do not forget to hit like, comment for some questions or clarification, and lastly, hit the subscribe button. So guys, let's proceed. So, this is our first topic on our masterclass video, which is the basic integration formula. Basic integration formulas consist of four functions, which is algebraic function, trigonometric function, logarithmic function, and then exponential function. By this integration formulas, we are able to integrate some problems that might be difficult for us. First is we will tackle about the algebraic function, and algebraic function consists of a lot of formulas, which is number 1, the integration of 0 dx is just simply 0 plus c. Number 2, our second formula in algebraic function will be a dx. A will be our constant, so to integrate this, we will put our constant outside, which will be a dx. So, to integrate the dx is just x. So, we will copy our constant, which is our a. The integration of dx is x plus c. We should not, also, one of the most important in integration is our letter c. Our answer will be wrong if we will forget the letter c. Number 3 is we will integrate the constant with a variable, which is our x, and then dx. As you can see in number 2, we'll just do it like this, but our variable will be inside our integrating sign, which will be a, the integration of x dx. In this formula in number 3 is simply a power formula of integration. We all know that in x, there is a hidden 1. So, what we are going to do, which copy the a, and there is a 1 right in above the x. We will put 2, 1 plus, x, and then the 1 plus 1, and then the denominator also 1 plus 1 plus c. Or our final answer is ax squared all over 2 plus c. That's it. Our number 4 is, let's try a x squared dx. Same process in number 3, a x squared dx. To integrate this, right, we will add 1 to this. X, 2 plus 1 is 3, right? 3, and also to our denominator, we will add 1, which is 3 ax plus c. For clarification, we add a denominator, which is, this is a rule when our variable has exponent. To clarify it, another example which will be a x n dx. Rn here will be our exponent. A, put the constant out, a x n dx. That's like that. So, should be a rx. N is our exponent, so copy the n. It should be always plus 1. Plus 1 all over n plus 1. That's it. That's our formula in power if our variable has exponent. And do not forget the letter C. That's it. So, we will proceed to our sample problems. So, number 1, for example, let's put sample problems. Sample problems. The integration of, let's make it easy. 2 x squared dx. In this number, we will apply what we've tackled earlier, which is the formula in power. If our variable has exponent, put the constant out, which is our 2, our constant. Our variable is x squared, which will be our we will integrate this x squared dx equals, copy the 2 times, which is x squared, copy the x squared. The integration of x squared is just put 1 all over 2, which is 2 because the exponent of x is 2, and add 1 like that, plus c. So, our final answer will be 2 times x will be we'll put the 2 in our numerator. X is, the exponent of this is 2 plus 1 is 3 all over 3 plus c. And that will be our final answer. To check if our answer is correct, we will just simply derive our answer, which is 2/3 x cubed plus c. The derivative of this is just simply 2x squared. As we all know, the integration is just kabaliktaran ng derivative. That's how we check if our answer is correct or not. Our second example is, we will try a fraction. Let's try 5 all over x squared. That's it. We will try to integrate the 5 all over x squared. To integrate, we all know if we put if we will not try to make this a fraction, the exponent should be negative, right? So to rewrite, we will just put 5 x, and then our sign in our exponent should be negative. That's it. And dx. That's how you write or rewrite a fraction if you want to integrate it. Equals. So, you see, it will be integratable, right? We'll just put the 5, which is our constant, outside. 5x negative 2 plus 1 all over negative 2 plus 1 is just negative 1. Our final answer would be 5x negative 1 all over negative 1 plus c. And that is our final answer. Oh, it is not pleasing in our eyes, right? We'll just simply rewrite this. If we rewrite, it should be negative 5 all over x. That's it. That's how you integrate a fraction using the power I mean using basic integration formulas. Our second topic in basic integration formula is the function of logarithmic, exponential, and trigonometric function. First is we will tackle about the logarithmic function. Logarithmic function consists of three different kinds of what you call that formula, which is the if our problem is d all over du, the answer is ln u plus c. If there's an if here, if ru is equal, ru will be less than 0. Greater than 0. Number 2 is if our u is less than 0, the answer will be ln negative u plus c. And the third is du all over u all over u. If our u is not equal to 0, the answer will be ln the absolute value of u plus c. That's it. And we will proceed to our sample problem. Sample problem number 1 will be the integral of 2 dy all over 3y minus 4. In this problem, I will be using the u substitution. Let our u will be our 3y minus 4. The derivative of 3y minus 4 is 3 dy. 3 dy. Since 2/3 is our what you call that, our constant, we will put our 2/3 here. Let's put our constant out. The derivative of 3 dy all over 3y minus 4. So our final answer will be 2/3 ln 3y minus 4. It's minus 4 plus c. That's it. Our final answer. Number 2 is we'll just put a simple problem. The integral of 1 all over x plus 1 dx. It's just simple because it is written in our formula in what I've shown you earlier. So it's simply ln absolute value of x plus 1 plus c. That's it. That's our final answer. It's just simple, right? The third is the exponential function, which is consists of two formulas. Number one is if the integration is Euler's. E is means Euler's. It's Euler's. Euler's. The integration of e raised to u du. The answer is just simply e u plus c. The second is if a, which is our constant, u du, is the answer is au all over ln a plus c if our a is greater than 0. So let's try a sample problem. Problem number 1, which is the integral of Euler's raised to 3x dx. In here, let our u be our exponent, which is negative 3x. The du, which is the derivative of our u, is negative 3 dx. So that's it. And also in this, we will have a balancing factor since we don't have a 3 here. So it should be equals to 1/3. Our balancing factor here is 1/3. 1/3. It's negative 1/3. Negative 1/3. The integral of e raised to 3x negative 3 dx. That's it. And we all know the integral of e raised to negative 3x follows the formula of our formula number 1, which is this. Oh, like that. You'll just simply copy the 1/3, the Euler's negative 3x plus c. That's our final answer. Our problem number 2 is the derivative of dv all over ev. Remember the formula I thought earlier in algebraic function. If the given is fraction, right, our exponent will be negative. So the integral of e, we put negative v dv with respect to dv. I mean with respect to v. So let's put, that's it. Oh yeah, it follows the formula of our formula number 1. Oh no, oh there's a negative here, we put negative here. So since this is a fraction, we will put negative here outside the integral sign. Negative the integral of e raised to negative v dv. That's it. I have to integrate this. It simply follows our formula number 1, which is this. So the integral of this is just copy the negative sign, which is outside the integral sign, e raised to negative v plus c. That's it. We can rewrite this actually if we want it to, if you want it in fraction form, which will be which is negative 1 all over ev plus c. Either of these two is the correct answer. The fourth topic is about the trigonometric functions. These are the list of 6 trigonometric identities, which is, with their integral. Number 1 will be the integral of sine bx dx. Let our b will be our angle, and then x is our variable. The integral of sine bx dx is simply negative cos bx all over b plus c. For what our value on our angle, which is rb, should be our denominator. The number 2 is the integral of cos bx dx is simply sine bx all over b plus c. The third is the secant squared bx dx is the integral of it is tangent bx all over b plus c. The fourth is the cosecant squared bx dx is equals to negative cotangent bx all over b plus c. The fifth identity is the integral of secant bx tangent bx dx is the integral of it is secant bx all over b plus c. And the final is the cosecant bx cotangent bx dx is negative cosecant bx all over b plus c. So let us proceed to our sample problem. Our number 1 practice problem is the integral of cos 3x plus sine 2x dx. In this problem, we will be using the simple substitution in terms of trigonometric function. As we all know, the integral of cos is sine, so the answer should be sine 3x all over 3. Our 3 here is our angle. And then the second term is the integral of sine 2x is negative cos 2x all over 2 plus c. Our final answer is sine 3x all over 3. And then plus times negative is negative, so we follow the negative sign, so it should be cos 2x all over 2 plus c. The number 2 is the integral of sine x cos x dx. Let's recall the one of the trigonometric identities, which is sine 2x all over 2, is simply 2 sine x cos x. So we will write our sine 2x as our new sine 2x all over 2 dx. In this term, we will start integrating. We have a balancing factor, which is 1/2 the integral of sine 2x all over 2 is cos sine 2x all over 2 plus c. To simplify, our final answer should be 1/4 cos 2x plus c. Our second topic is about the general integration formulas, which consists of four formulas, which is number 1 is the integration of u raised to n du is simply u n plus 1 all over n plus 1 plus c. if n is not equal to -1. This formula is a power formula. Number 2 is the integration of du all over u is equals to ln, the absolute value of u, plus c. The third is the integral of e raised to u du is eu plus c. And lastly, the integration of a raised to u du is equals to au all over ln a plus c. Let's assign our u value and yes. Our u here is our denominator, which is the e raised to y minus 1. The du should be the derivative of our u, which is e raised to y dy. We don't need any balancing factor here since our u and du comply all we need in this problem. So the integral of e raised to y dy all over ey minus 1 is the integral of du all over u, which is in our number 2 formula, is ln e raised to y1 plus c. That's our final answer. Our second practice problem is the integral of v dv all over 6v squared minus 1. Our first step is, let us assign our v, which is 6v squared minus 1. The derivative of 6v squared minus 1 is 12v dv. As we can see, we don't have any 12, which is irrelevant in our problem. So by this, we will have a balancing factor, which is 112. And we will put 12 here. So to balance, we have to put 1 over 12 and 12v dv all over 6v squared minus 1. After that, to cancel the 12, we will simply cross out. And we will cross out the 12 since we already have a 1 over 12 here. Our final answer will be 112 ln, and our u, which is 6v squared minus 1 plus c. And this is our final answer. The last part of this lecture video will be the integration technique, integration by parts. The formula of integration by parts is the integral of u dv equals uv, the integral of v du. This is our number 1 problem. First is we'll assign our u. Our u here is x. Our du is just the integral of, the derivative of u is dx. Our dv is e raised to x dx, and our v is the integral of dv, which is e raised to x. So we will follow our formula, which is uv minus the integral of v du. Our u is x, our v is e raised to x, minus the integral of ex dx. So our final answer is x minus the integral of ex. The integral of e raised to x is ex plus c. This is our final answer. This is our second sample problem in integration by parts. As usual, our first step is get the value of our u. Our u here is y. Our du is dy. Since dy is the integral of y, our dv is this cosine for y dy. And the integral of cos 4y dy is sine 4y. That's it. And also we have a balancing factor, which is 1/4. So one-fourth, I write 1/4 since this is our balancing factor. Y sine 4y minus the integral of 1/4 sine 4y dy. After this, we'll just integrate this part to so our final answer is 1/4 y sine 4y plus 1 all over 16 cosine 4y plus c. And that is our final answer. So that ends our lecture, which is about the basic integration formula, the general integration formula, use substitution, and lastly, the integration by parts. That's all. Thank you.